So this is the lecture for chapter 12. And in chapter 12, we're looking at simple regression. And I've put simple in quotes because it isn't simple, but it is where we begin our discussion of regression analysis. Regression analysis is useful when you have a continuous variable that is used to predict the variation in another continuous variable. Before now, we've looked at situations where we have two categories of outcomes, and we've compared those with means test, differences in means test when there's two groups, and analysis of variance when there's more than two groups. So regression analysis also allows the testing of those two situations. Okay, and we'll get into that in chapter 13 when we think about multiple regression, when we have more than one variable affecting another. Okay, so the analysis begins with visual displays and correlation analysis. Okay, a visual display is when the two variables that you are analyzing are illustrated in a scatter plot. A scatter plot displays each observed data pair as a dot. Okay, and it can illustrate the strength of the relationship between the two variables. So here's an example from the textbook, and the two variables are state average fuel prices, where one fuel price is regular gas, that's on the horizontal axis, and the other fuel price is premium gas, which is on the vertical axis. So it shouldn't be a surprise that increases in the price of regular gasoline would be positively correlated with increases in the price of premium gasoline. And that's exactly what this diagram shows. This is a positive correlation between the two prices. So correlation analysis was something that we covered first in chapter 4. The sample correlation coefficient is one way to measure the degree of linearity between two variables x and y. Okay, so the correlation coefficient, the notation is R, and the formula is the sum of squares between x and y divided by the product of the square root of the sum of squares of x and the square root of the sum of squares of y. Okay, the correlation coefficient was based on the covariance statistic. And if you recall, the covariance statistic was difficult to interpret because the units of analysis depended on, or the magnitude of the covariance depended on the unit of measurement for the two variables. So the correlation coefficient, this adjustment, allows the correlation to range between -1 and 1. Okay, and let's just review what these sum of squares look like. The SS of xy is the product of the deviations of each variable from its mean. So x sub I, as I goes from 1 to n, where n is the sample size, so for each x variable, we subtract the mean and estimate the difference, and then we multiply that by the same measurement for the other variable, which is denoted here as y. Okay, and in the denominator we have the sum of squares for x, which is the squared deviation from the mean added up over all of the data values. And then we do the same thing for the y variable. Okay, so we illustrated one correlation scatter plot between two variables. And so this next slide illustrates all of the possible measurements. So this goes from a strong positive correlation, which we saw with the gas prices, all the way to no correlation and a nonlinear relation. So positive correlation, the two variables move in the same direction, and so the scatter plot goes from the southwest region of the first quadrant to the northeast region of the first quadrant. Okay, here we have the correlation coefficient, correlation between x and y ranges from -1 to 1. And you can see that the higher the correlation here, it's 0.9, the tighter the dots, the tighter the pattern of the dots. As the correlation falls, this one is 0.5. The pattern of dots is, the dots are further apart, but you can still see that they are upward sloping. Okay, and the mirror image of the weak positive correlation here is displayed to its right. There's a weak negative correlation, and then below the strong positive correlation is a strong negative correlation. Okay, note when there's no correlation, the scatter plot, it's difficult to detect any pattern between the two variables. And we can't lose sight of the fact that even though there's no linear relationship between the two variables, there might be a nonlinear relationship between two variables. So here the correlation is going to be 0. Okay, but there is a relationship between x and y. You can see here that as x increases, y increases up to some point, and then as x increases, y decreases. And there's a number of variables in economics and business that might display that sort of pattern. Okay, so there is a t-test for the correlation coefficient. And the t-statistic is equal to the correlation coefficient multiplied by this term under the radical. So n is the sample size minus 2, okay, and that's the degrees of freedom, and then you divide that by 1 minus the correlation coefficient squared. Okay, and this t-statistic would be compared to a t-critical value to determine if the correlation coefficient is statistically different from 0.